thanks so much, Adam. It's great to be here. Thanks for inviting me. I'm Ashley Cagle. I am a structural engineer. I work at Woodworks, which is a nonprofit organization located in the United States. And what we do here at Woodworks is we provide free project assistance to architects, engineers, contractors, developers, really to help encourage the use of wood in commercial and multifamily construction. So here in the United States and across the world, single family is already built out of wood, but there's so many other construction types that could be built out of wood that aren't. And so we're really trying to help people understand where they could use wood. We do cover both light frame and mass timber. But of course, today I'm going to be focused on mass timber construction. I got, as I said, I was a structural engineer. I consulted for about 10 years. And interestingly, I graduated with my master's right in the middle of the recession, and it took me a while to find my first job. But I had these grand goals of, working in a big city and designing some landmark structure. But at the time, jobs were slim pickings, and I took the first job I got, which happened to be designing mid-rise, light frame, multifamily apartment buildings. And I was not super excited about it. In college, I spent all my time studying steel and concrete and these big, cool structures, and here I was designing kind of little things that I didn't appreciate at the time. And I had a lot of friends doing much cooler projects, seismic base isolation, and I had a bunch of friends working on the high roller, the Ferris wheel in Las Vegas, and here I was designing apartments out of wood, and people didn't really appreciate what I was doing. I didn't really appreciate what I was doing. But as I moved through my career and I changed firms a few times, kind of seeking out those bigger, more landmark projects. And I kept being put back on wood projects because I had this unique skill set that not a lot of people had. And so over time, I got to work on some pretty cool 4 or 5 story over concrete podium wood structures, got to study rigid diaphragm analysis of wood frame structures, some of the fire resistance detailing nuances of wood construction. And I really started appreciating it a lot more. And so about 3.5 years ago, I got this opportunity to work at Woodworks, which helped me broaden my reach. Now I get to work with project teams all over the country, helping them overcome those same hurdles that I faced as a designer. And I'm specifically focused on sustainability. So I lead our carbon initiative, which focuses on the embodied carbon of materials and life cycle assessment so that we can really evaluate the choice of materials that we're using in our buildings. And that has just really tied a bow on the package for me. It's the ability to help people and also make a difference in the environmental performance of our built environment, which is just, it checks all the boxes for me. It's really exciting.
That's amazing. And checking all the boxes. I remember, last year I did some rough numbers on if you, from an individual point of view, if you design a mass timber building instead of a concrete building and you're the person instigating that change, from right off the bat, you're pretty much offsetting lifetimes of greenhouse gas emissions. So it doesn't take many of those buildings to actually make a good impact in the world.
Yeah, that's such a good point, because I think we're all looking at our individual decisions. Do I avoid using single-use plastic, or do I, not take that car trip to the grocery store? And then as structural engineers, I feel like for a long time, we didn't really have much of a say in the environmental performance of our buildings. And now that we're really focused, not just on how energy efficient is your building, but what is it actually built out of? What are the structural materials you're actually using? And it's such a great way that mass timber comes into the equation and is a new option for structural engineers to really make a difference.
Mm. So you made the call at the start of your career, and it didn't seem like it was the hottest topic at the time, timber,
Yeah.
in a boringer context. And now it has, the category is in a different dimension now. So what has the tailwinds been basically? And I always get the headwinds and tailwinds mixed up sometimes, but tailwinds are the good ones for this category, and from it, and most recently, you know, especially in your area of sustainability.
Yeah, well, I think it's just really cool, again, just from a structural perspective, to have this new material to work with. I think a lot of people just get excited about that technology. You know, how the construction industry has been, I'll say, relatively stagnant for the past century. We kind of have been building the same way. And here, all of a sudden, we're at this unique time where there's a brand new structural material that's allowed by code. And I think that's, at least here in the United States, has really been the inflection point for when mass timber has really started taking off. So CLT, in particular, cross-laminated timber, was adopted into the 2015 IBC as a recognized building material. And then in the 2021 IBC is when the new tall wood, what we call the tall wood construction types, were introduced that now let us go up to 18 stories. And while I think it's really important to remember that the majority of our buildings are still low to mid-rise, I think it's really brought renewed attention to this new material and the opportunity to use it in all types of buildings. So from that kind of code standpoint, I believe at the last count of half of the states, so 25 out of 50 in the United States, have adopted some form of the 2021 tall wood provisions. And so, you know, half of the country, I don't know what that is in terms of population. It tends to be the more populated states that have adopted that. So let's say more than half of the United States can now build tall mass timber buildings. From a sustainability standpoint, though, I think that's been a huge driver as well. There's been, I like to think that it started kind of grassroots. You know, there was interest in driving down our climate impact from buildings. We know, I think we've all heard, you know, somewhere around 40+% of global greenhouse gas emissions are due to the built environment. And building materials themselves account for 15%-ish of that. And that's largely attributed to steel and concrete, partly because they are the most used materials, but also because they have a lot of emissions associated with them. And so, you know, interest in solving the climate crisis, as well as various policies, federal and state policies that have been trialed, and it's ever evolving. You know, the political landscape here in the United States, it's always changing, and it really depends on where you are. But there are a lot of policies in place really pushing for greener construction. And we are starting to see more of that focused on, again, embodied carbon, the materials, rather than just how much insulation are you putting on your building, how many PV panels are you putting on the roof.
That's
So
great.
I think one of the more interesting policies that's about to go into effect that I'm really paying attention to is in California. They are starting July 1st, there's going to be a new policy, part of the Cal Green Code, so the California Green Building Code, that will require you to look at the embodied carbon of your buildings, either by reusing existing buildings, doing an LCA to kind of get a holistic picture of your ability to reduce carbon impacts, or through prescriptive global warming potential limits for certain materials. And so, as often is the case here in the United States, California will adopt, their own version of a code or policy, and then the other states kind of see how that plays out. But I think it'll be really interesting in the coming years to see how other like-minded states adopt similar policies. Because as far as I know, this is the first embodied carbon policy that's actually been written into a building code in the United States. So really, really exciting stuff there that I think is going to continue to drive people towards mass timber.
That's amazing. And then the innovation that's required to meet the building codes, and what are I don't know if you know off the top of your head the specifics on the reduction targets, because I just speaking out aloud, it's like I feel like at a certain point mass timber is the only option that's possible, you know what I mean? And it's like there's only a certain range that you can actually do with supplementary cementitious materials, with concrete, or green steel is not necessarily, like green virgin steel is not necessarily ready to go. So it's sort of like what are those, and how how influential do you think these adoptions going to be?
Yeah, well, for the California policy for Cal Green, I know it's a 10% reduction, which is not huge, and you could easily get that by changing, like you said, your concrete mix. But I think that it's the first stepping stone, and the goal is eventually, every code cycle, this will become more stringent, and that limit will start increasing. There's different, I think another example maybe would be LEED, where you can get points for showing certain percentage reductions. And I believe that goes up to 20%, maybe 25%. Speaking without notes here, but 20-25%, somewhere in that range. And that's starting to get to the point where, depending on your building type, mass timber really becomes one of the few options to make those types of reductions. I would love to see something like a mandatory 50% reduction, which we can definitely achieve with mass timber. But, baby steps for now.
Yeah, it's one of those things, like we need help from other material categories as well, right? Because when you get at those categories, the volumes are just like absolutely crazy.
Oh yeah, sure.
I might just put I'm sure in your role you get all sorts of like devil's advocate sort of questions on sustainability. So I might just like reel off a few of the ones I hear sometimes and see your thoughts on it. So some of the things that we hear is like, is there enough land? So the whole land question, I'm sure you've got a lot of questions on the past. Also around inclusion of biogenic carbon, can you do it? What is the end of life scenarios? What should we be assuming for projects for end of life? So I guess there's three cans of worms that are open in those areas, but maybe just over to you, and what are some of the questions you get and thoughts on that?
Yeah, well, from a land perspective, I think there's two ways I could approach this. I think one of the questions is, if we build more wood buildings, are we going to run out of trees? Does that mean we're, cutting down too many trees? And we actually have a pretty good study for the United States, at least, that shows it looked at most aggressive estimates of mass timber growth, and what the percentage of board feet of lumber increase that would be over 15 years, compared to the least amount of estimated forest growth over that same amount of time. And there's still a significant delta there, that even if we max out what we're using in terms of wood for our buildings, we still we have plenty of buffer. So again, here in the US, which I believe also includes Canada, because we do a lot of trading with them. So most of what I'm talking about applies to both US and Canadian forests, because we share a lot. But so that, that study helped answer that question about, we're not running out of trees. In fact, we have more trees on the same amount of land than we did 65 years ago. So that's, I think people aren't really aware of that, but here in the United States, that is definitely true. Your second question about biogenic carbon accounting, that's one of my favorite topics, but it's hard to talk about. So we've written a lot of resources about biogenic carbon. When I started on this topic about 3 years ago, there were a lot of people who didn't know what it was or didn't know whether they should count it. So we kind of went back to the basics of what the international standards say regarding biogenic carbon accounting, and ISO 21930, which guides the development of environmental product declarations, does say that not just that you can, but that you shall include it. So that code language indicating, yes, you have to include it. And it gives some parameters around that, sustainable sourcing, which we have here in the United States and Canada. And then it talks about how you include that with a -1 in and a +1 out. But your question about end of life is really where the rubber hits the road, because if all that carbon leaves your system at the end of life, if your building burns down, God forbid, or the products are removed and incinerated for energy, even if that happens, you have held on to that carbon for the 50, 100, 200 years that your building was in use. And that means something. There is a time value of carbon. And so we're not quite there in our life cycle accounting yet. There's a lot of work being done on that, but there is value in holding on to it, especially when we're looking for near-term carbon reductions to meet 2050 goals. And that also buys us some time to figure out how to build up the infrastructure for reuse and recycling of these materials more readily. So there's been a number of projects in the United States that have focused specifically on design for deconstruction or design for next use, kind of that cradle to cradle theory, where we're keeping products in circulation. And I think that for right now, that's really what designers can do. Think about how you're putting your building together so that it can also be easily taken apart. And I know, based on how we're already seeing movement in this area, that in 50 years, when your building needs to come down, there will be options available. There will be, venues to reclaim and then reuse that material, even if it's not quite in place yet.
Yeah, totally. And then, I guess with building information modeling, which is so native with it, from the outset, like what value is salvageable, as opposed to some old buildings with handwritten drawings and you don't know what the hell, whether it really is.
Yeah. Yeah. And kind of keeping track of what was the design of all of these pieces, and especially these customized pieces, and what's the strength value, and how were they designed originally. So I think there's maybe even more potential, just because of how customized a lot of these mass timber products are, to really keep track of that in a meaningful way so they can be reused.
And what about, do you have any thoughts on the overall disassembly ability? If that's, I just made up a word, I think, but for these buildings relative to, concrete, in situ concrete buildings, and is the potential for the practical means of disassembly a possibility, you think, in 50 years?
I definitely think that, if you just kind of think about how these pieces go together like Legos, and then they can come apart like Legos too, in a mass timber building. In a concrete building, it's cast in place. It's board right there. You can't take that. You can't undo that. You have to, you might be able to cut out sections of it, but ultimately it gets ground up, and if it's reused as aggregate or road bed or whatever. It doesn't become a new concrete building. You don't take a slab of concrete out of one building and put it directly into another building. That's just not feasible. So I think just inherently, especially as we look at more mechanical fastenings of mass timber connections. I'm sitting in front of a picture of one right now where, you know, everything's in bearing and screwed connections that can easily be unscrewed and taken apart more easily. Of course, there's still going to be challenges with the logistics, the size of the panels, the time and labor that it takes to take apart a building. But again, I think as we continue to value that or value it more and more in the coming years, that will be a problem that continues to be solved. We're already seeing solutions to it now.
One of the other
Our buildings are only, you know, 10, 15 years old in the United States. So we still have some time to figure it out, which is partly why we don't have all the answers about what happens to mass timber at the end of life, because fortunately, none of them have reached the end of life yet.
Yeah, that's a good thing. That's a good problem.
Yeah.
If you got data on it after 15 years, that'd be more of a problem.
Right.
Answer the question, hey? One of the things I wanted to ask you about is the state of play of the education in the US. You've obviously got a growing industry, and you know, how is the education serving that? And you know, maybe just tie it to how you learn. How much did you learn at university versus how much was it through scars on jobs at the start of your
Right.
career, and maybe what, you know, if that was necessary or not, if the education was there. So what do you reckon?
Yeah. Well, that's a great question. And I could speak from my personal experience that I had a great education. I, you know, did 4 years of undergrad and 2 years of a master's program at 2 different schools, highly regarded, but both of them had one wood class and it was optional. I did not have to take a wood class to graduate. I believe there were some wood questions on my licensing exam when I got my professional engineering license and my structural engineering license, but definitely weighted towards steel and concrete. That is what the majority of education in the United States for structural engineers is focused on. I can't speak to the architectural programs. I think they're similar though. But you know, there's a big need, which is partly where Woodworks, our organization, comes in. We don't provide college level education, but we know that there's a gap in knowledge in the professional engineering and architectural communities, and so we help, you know, fill that gap. At the same time, though, especially with this huge growing interest in mass timber, there are more universities starting to adopt wood courses. Also in the contractor, construction management type programs, we're seeing more universities starting to adopt, you know, courses specific to mass timber. And in fact, through our construction management program, we've supported some of those with mock-ups so that they learn how mass timber pieces go together and how is it installed, how is it different than other building materials, or importantly, how is it not that different? You know, you could get some steel erectors to put up a mass timber building. It's, you know, intuitively similar. So I think that there's a lot of growing interest, and I'm really excited for the next generation of engineers to come out of school with this passion for wood construction that I did not have, that took me a while. You know, my very first job, day one, they sat me down with a Woodworks paper and said, study this design example, because you need to know how to design a wood building. And like I said, you know, for the first 3-ish years of my career, nobody really cared what I was working on. It wasn't glamorous. And now it is. I think now if you're somebody working on a mass timber project, it's like everybody wants to hear about it. Everybody wants to know what you're doing. You're on the cutting edge. And I think that's really cool.
Talking about the cutting edge, you'd be surprised, because I think the light frame market for you is like 3, 4, 5 stories. Correct me if I'm wrong, and that's not the case in Australia. So it's like that actually is the cutting edge in Australia. If you can get light
Yeah.
3, 4, 5 stories, so it's actually really cool. On that education, I guess that without it being at university, at the end of the day, engineering companies are footing the bill for education of professionals, you know what I mean? Unless they're proactive to do it on weekends. But I mean, that just all stacks the concrete, steel versus timber option. Concrete and steel taught at university. Do we have to educate our workforce to design it? No. Do we do for mass timber? Albeit with Woodworks is obviously the best educational pathway available thanks to Woodworks, but it's still that adds to the overall costs, hey, and that education is something that needs to sort of help. And I guess students, do you think, are the most progressive? So I'm guessing the willpower is there from the students, and as you said, universities are just starting to catch up.
Yeah, yeah. And I think that plays into the emphasis on sustainability. I think a lot of universities have had sustainability focused courses long before they had wood courses. I certainly took a number of sustainability focused courses during my undergraduate program, and again, only one wood course available at the time. So I think as those two things start to merge together, and people start thinking about, again, the impact of the structure on environmental performance, it's going to be a natural combination that more universities will start teaching it. There are of course a number of research institutions across the country that are working on dedicated mass timber research, and so those are good options, for getting more hands-on experience or more education at the collegiate level. And then also we're seeing a lot more universities start adopting mass timber buildings on their campuses, again, as part of their sustainability goals. And so I think it'll be interesting to see if that plays a role in the type of education that's then provided on campus.
That's amazing. I'm aware at Woodworks you've done some case studies looking at the cost effectiveness and LCAs, the relative performance from a sustainability point of view. Is there any sort of headline numbers you can talk about, or headline, facts about some of that research that you've been looking at?
Yeah, we have one comparative LCA published on our website today, but hopefully by the time this podcast goes live, we'll have at least 2 more on our website. We have probably 5 or 6 in the works for this calendar year. So they're about to come out. The floodgates are going to open. We've been working on this research for a few years now. But the one that you can look at for sure right now does look at the global warming potential of a mass timber superstructure. So this was a building that had a concrete podium. And so, really just focusing on the part that could be mass timber or could have been steel or could have been concrete. Looking at those 3 options from a carbon perspective and then also relative costs. And what we saw was from a global warming perspective, steel was about 3.25 times, I'll say, worse, higher, more emissions than the mass timber superstructure, and concrete was more than 4 times worse. And then cost wise, there is a delta. So in that case, for that particular market, steel was the cheapest option. And what was interesting about this study is that they looked first at just material costs. And I don't remember exactly what all the numbers were, but when you look at material costs, the cost delta looks a lot bigger for mass timber. But when you start thinking about the kind of added benefits, the speed of construction, lower labor costs, you have fewer finishes and things to install. All of those kinds of things add up and are often overlooked, I think, at the beginning of the project. You just get material bids back and mass timber dies because it's 20%, 30% higher. But when you add in all those other benefits and you start looking at the whole project cost, in this case, mass timber was only about 2% more expensive than steel, with huge, giant global warming potential savings.
Hmm.
And so I think the next iteration of this, or where the industry is starting to move, is how can we provide financial incentives for those carbon reductions? How can we put a monetary value on those reductions and bring the cost down even further? Because if you put a dollar cost on carbon and mass timber is, a quarter of the impact of concrete, then your cost delta is also wildly in favor of mass timber. So there's a few people, a few different organizations starting to look at that. It's again kind of an ever evolving landscape here in the United States, but really excited to see where that goes to help bring that down.
Yeah, that's so interesting. It just speaks to that point. Like if you got a quantity surveyor at the start of a project or the team doesn't look at all at the benefits, then there's just no chance of the job going ahead. Like no one's going to do that for that 20% increase. And like just the need for having a quantity surveyor to actually look in and get, hey, what is the program savings here? And to your point, it's sort of like there's such a variation in that. How can we optimize the program savings and design for manufacturing assembly to actually, like you said on this project, get to 2%, but maybe who knows if every project's optimized to its maximum and the manufacturers are happy with their throughput because it's designed in a certain way and the installers are doing, then who knows, you can actually get the cost benefits with, and I hear anecdotally, right, there are some projects that feel like they get cheaper. Am I right? Is that the same for US, some projects?
Yeah. We have seen some that mass timber has definitely come out as the cheapest option. I think there's a perception that mass timber is always going to be more expensive, and that's definitely not true. But it also really helps when you look at the whole picture, because there's so many additional savings that don't come across just in the mass timber material cost.
That's amazing. Well, it's so interesting, this conversation. Is it what do you see as the future of mass timber construction? Just an open-ended look at what's ahead for the whole industry in general.
Yeah, well, I think we are still predicting exponential growth here in the United States. So on Woodworks website, there's a little chart that shows the growth of mass timber in the United States, the number of projects that are in design or under construction, and it's a hockey stick shaped chart. It just has exploded again, especially after the adoption of various building codes that have expanded the use of it. So I think it's going to continue to grow. I think it's going to continue to be more of a direct competitor, I'll say, with steel and concrete. I think it's going to be one of those materials. It's not just, is this building going to be cast in place concrete or steel frame or mass timber, I think is going to start to be the conversation, and more people will become familiar with it. There's still a lot of work to be done in terms of education of designers, of developers and building owners who may not even know that this is an option, contractors, so that they feel comfortable building with it. Anytime you don't know the material, you don't know what you're doing, you're going to add cost because you have to spend the time to learn it, and you don't know what to watch out for. So all of those pieces that come together, and I think just as more and more of these projects get done, as we can showcase more of them and like tour people through them, that's always really impactful. Once you see it in person, like, oh wow, this is real, I can do this. I think I only see it growing from here.
Yeah, 100%. Well, what an exciting future. If people want to find out more about yourself, Ashley, Woodworks, any of the research we've been doing, where should people go?
Well, I would start with the Woodworks website, woodworks.org, O-R-G. And if you want to find me, I'm on LinkedIn. You can also find me on the Woodworks page under the About Us tab with my email there. Or again, on LinkedIn, you can always message me there, especially if you have carbon or LCA questions. I love to talk about biogenic carbon and what's appropriate, where do I count it, you know, all of that kind of stuff. But happy to help anyone talk through making their mass timber projects a reality.
100%. I think people will take you up on that. I haven't really heard much about the time value of carbon, that as a concept. It's sort of just like light bulbs went off a little bit. So it's been amazing chatting to you today, Ashley, and look forward to meeting you in person and of course at the Portland conference. So anyone listening right now, of course you're going to be there. And yeah, been amazing chatting to you, and thank you.
Thanks so much, Adam.